So this is a walkthrough of sorts for the initial task for the Arduino board. And so there were a number of issues folks were having in class, and I can stress that it's really, really important to follow the instructions. So I'm going to share my desktop and run a few applications to walk everyone through the steps as listed in the task sheet. And so task sheet, BigMac Attack for today, there's some references there, the Arduino language reference, the getting started for the board, and the Blink demo. So all of the pieces you need are absolutely there. You're going to need a laptop or some machine. You're going to need your Arduino Uno Wi-Fi, which is this board, and you're going to need the USB AB cable. Now, I realize that some of you don't have the boards yet. We're going to make the best of it using the resources that we have in the lab. Here's my USB AB cable. And if you're on a Mac like I am, you're going to need to have a converter adapter, which converts from USB Type-C to USB AB cable. And so with that, the instructions, and it's going to be really, really important to follow each step. Resist the temptation to want to jump ahead because that's where problems arise. So the first instruction, locate and install the Arduino IDE for your platform. Use the 2.0 version for your machine versus the cloud-based version. And so we start out, and I'm going to bring up a browser, and I'm going to go to arduino.cc. And that brings you to the main site, as you can see here, for my interface. And so the first thing I'm going to do is go to software, and you can also Google search this. And the software in particular I'm going to install is the Arduino IDE. Now, the 2.0 version is not the 1.8 or 1.x version. If you scroll down, you're going to see Arduino IDE release candidate 3. And so you're going to install this. So on Mac OS, I download it and install. So let me go ahead and reinstall it. I'm going to save the install file somewhere on my machine. And when it's done downloading, I go ahead, I click install. And for Mac OS, it prompts me to load it into applications. So I'll do that. Now, of course, I've already installed it. And so it might prompt me to say, do you want to overwrite it? So I'm going to say replace. Go ahead and replace. But for you, if you haven't yet installed it, you're just going to accept the install. And so it will run. It'll take a little bit depending on your internet speed as well as on the speed of your machine. But after roughly maybe a few seconds to a minute or so, your IDE will actually install. So we'll give this all the time it needs, and we will let this install finish. And when we're done, we're going to put it on the taskbar specifically because it makes it easier for Mac OS. And so I'm going to go down here and I'm going to delete. You will not be deleting from the taskbar, but I'm pretending as if I were installing it from scratch on my machine. Now, once it's done, I go to applications, and this is a Mac-ism, and I'm going to look at Arduino IDE that I just installed, and I like to drag it to the taskbar for the Mac because it makes it a little bit easier to run because it's on the desktop. So let me go ahead and we'll drag it to the taskbar. And now I'll click on that icon to run the Arduino IDE. And so that's the first step. It's going to expand it, and depending on your platform, you might get a security warning because you are trying to run something that you just downloaded. And so that being the case, it says you just downloaded it from the internet. Excuse me. Do you want to open it? And that's a security thing. Your platform might be different depending on what you're running. So I go ahead and you see the splash screen and the IDE is starting for the first time. Now, with this, I've already set it up so it has some configuration files already established. But the first thing you're going to do is you're going to navigate around the menus to familiarize yourself with the environment. Do not jump ahead and actually look at the instructions. So I just downloaded release candidate for the 2.0 version of the Arduino IDE. Now navigate through menu choices and familiarize yourself with what they do. So I go through, I look at the menu, file, new, open, open recent, sketchbook, examples, etc. Edit, that's about editing things. Sketch, okay, I can verify and compile, I can upload it, that's the staging we talked about. Include library, add a file. Tools, format, I can select the board, etc. So now that you've familiarized yourself with the menu choices, go to the preferences for your IDE, the third step. So don't jump ahead, actually go through the steps as they're listed. So if we go back, Arduino IDE, preferences, you'll see a menu pop up for the settings. Verbosity, show verbose output during compile. You can check that off. Upload, check that off. So go on to your IDE preferences, set the verbosity and warnings. And so here, compiler warnings, let's accept the default. You could say more warnings, no warnings, etc. And so that's going to affect or impact what you see when you compile your sketches and upload them. More is better because it tells you information about what's going on. So now that I've done that, I click OK, and I'm ready to go to the next piece of information, the next step. So again, go through the steps carefully one by one. So set your working directory as appropriate. So now that I've gone through the menus, I say File, Arduino, Preferences, and you'll see here sketchbook location. So you can choose whatever directory you want, but set what the directory is where all of your work is going to be deposited. That's the next step. So click OK. Now, make sure you install the board manager appropriate for the Arduino Uno Wi-Fi revision 2. So we go in to the board manager, and you notice here along the left-hand edge of the application, the second choice is the board manager. It pops up a tooltip to let you know it's the board manager. You click that. So now you search for the Arduino Wi-Fi revision 2. Hit enter, and it prompts you with the install for the board manager for the board we're using. So here you'll see it says Arduino Wi-Fi revision 2. This board manager knows how to stage your bytecode for the particular board. If you don't have this installed, it might not work in talking, or will not work in talking to your board. And so again, follow the individual steps. If you skip this step, what will happen is when you try to compile and stage, it might not work and give you all sorts of crazy error messages. So you click install, and when you click install, it'll do its thing and install the board manager for the Uno Wi-Fi revision 2. And you notice here, it says Arduino Uno Wi-Fi revision 2, this particular Arduino Mega AVR board in the board manager, right? So when it's installed, it'll actually tell you this little banner here that it is actually installed. So now we know that we can support the Uno Wi-Fi revision 2. Okay, so that's our next step. So the next thing we do, locate and download the latest version of the Wi-Fi library for the Uno Wi-Fi revision 2, namely Wi-Fi Nina. So how would we find that? Okay, you could do a Google search. If you go to the Arduino IDE, the main website, let's go back to the main website. And in this main website, you go to documentation, reference. Click on reference, you see libraries, click on libraries, and if you scroll down, you'll see the Wi-Fi Nina. You could also search in the web page from this libraries section of the Arduino Uno libraries. And so it's important to note that Wi-Fi library for the Arduino Uno is not the same as the Wi-Fi Nina library. So you see here Wi-Fi 101, and you see Maker Wi-Fi 1010, and you'll see Wi-Fi Nina here. But you want to make sure that the Wi-Fi library you're installing is for the Uno Wi-Fi revision 2, which Wi-Fi Nina is. So you can click on Wi-Fi Nina, make sure you're reading the page. It has a different page for the library. So you click on that link. And here we see the releases. Take the latest one. So for this latest one, you click and it'll ask you to save the file. This is the zip file. I know that you can select things through the menu choice, but the instructions tell you to download the zip file. So please download the zip file. You click OK. It'll bring up a prompt to actually save this library. And in my case, it downloaded it. And you put this library someplace where you're going to access it later. Now, I've already done that. And so now, once you've done that download of the library, the next thing you're going to do is incremental development. Now, when you run your IDE, if you want to use that Wi-Fi Nina library, which we certainly do, you go into Sketch, Include Library, Add Zip Library. When you click Add Zip Library, it's going to prompt you to ask you to specify a location where it will find the zip library. So I've set up a directory called Arduino Projects, and in it, I've placed my zip library that I downloaded. You select it, and then you click Open. And this will add that library. Now, I've already added it, but I just want to show you what you should be doing to add that library. You need to add the zip library. That's exactly what the instructions state. So now that you've added that zip library through Sketch interface, now you're going to incrementally develop the Blink demo. Now, one of the things that's fortunate in the Arduino examples, they give you all of this. And so this is just to get you familiarized with menu choices and some of the basic APIs. So now if we say Sketch or File, Examples, go to Basics, and we look at Blink. Let's examine what this Blink demo is doing. So here in this Blink demo, we have some text, and we have two things. We have a setup routine, and we have a loop routine. Now, as I said, the setup is the entry point that's called when you want to establish your connection. Now, the first thing you're going to do when you set up, a little bit of explanation about serial communication for printing. Now, when you connect your Arduino board, it communicates through the USB port on your computer, and that communication shows up as a serial output. Now, in the upper right-hand side of your interface, there's a button called Serial Monitor. Now, that serial monitor, when you click that, it's going to bring up a console in the bottom of your system, and that console is going to display things that you print as output on your board through the API. Now, one of the settings you're going to have to set is this line termination. You're going to select no line ending, and 9,600 baud, that baud rate represents the speed for communication. But in your board, when you write your program, the first thing you're going to do is called serial.begin. And what that does is it tells your system to initiate the runtime for serial communication. And so the board is going to have to communicate at the same speed as the console. So here, if the console supports 9600 baud, the board is going to communicate at 9600 bits per second, or baud. So now, once the serial runtime is running, you want your program, your board, to wait until the serial port is initialized. And so we're going to say while not serial, checking for its runtime, for the runtime coming into existence, we're going to have semicolon, an empty statement. And so once this finishes executing, when we're on line 33 or greater, the system is connected and able to print and send output to the console. Now, this next part is the loop function. And the loop function is iterated in its call. So it runs it and then runs it again and runs it again and runs it again. And when this setup is called, that's only run every time you power on the board or hit the reset button. And so I'm going to plug in my board. And when you are setting up, it's going to be really important to verify where your operating system puts your board. Now, if I go into my settings for the Mac, preferences, system report, I can see under USB that I don't have a board set up on my USB bus. But I'm going to ground myself, and I'm going to take my board, and I'm going to plug in the USB connector to the board. And I'm going to then plug it in to the USB port. And when you plug it in, the board's getting power, and some of the LEDs will light. Now, one of the things that we see, let me go back in and do another system report. Go to USB. And now when I go to USB, you'll see on my USB bus, USB 3.1 on my system, we have this device. And if we select the device, you see the manufacturer is Amtel. This is the 18 mega processor that's on the board. Okay, so now we know that the board is connected to the system and it's recognized by the operating system. That's a key ingredient, is make sure your board is plugged in and recognized by the operating system. So the next thing we're going to do then is we're going to upload this sketch. After compiling it, we're going to upload it to the board. And so I'm going to click verify or compile, and we see some outputs, compilation complete. And now I'm going to do my upload. And this upload, here we go. Oops, forgot to load the board. So here, select another board, Wi-Fi revision 2, show all ports. Okay. And let's see. There we go. So now I upload the sketch. And if we look at the program, we see first thing that happens, the setup routine is called. We initialize the serial port, and then we have while not serial. And that's a blocking call, a blocking block, so to speak. And it just spins until the serial port for display of text is ready. And so the first thing it does, it says pin mode. And this pin mode uses a constant for two parameters, LED built-in and output. And what it's saying is go ahead and use the built-in LED, or which is port 13, which is this amber or orange-ish light that's blinking, and it's going to set it as output. Now, what this is doing is initializing a digital I/O pin to be output mode, and we'll talk more about the signal lines on the board. And so once that is established, the setup call returns. We know that you can do serial communication. And we know that the pin 13, the built-in LED, is set for digital output, this digital I/O pin. So then each time loop is called, we do two things. We go ahead and write a value of high, which is a logic true, logic true, and we're going to write that to this digital I/O pin 13, which is LED built in. And then we're going to delay 1,000 milliseconds, which is 1 second, and then we're going to write a logic low. So we write a logic high, delay for 1 second, write a logic low, delay for 1 second. Okay, so if we do this and we upload, you notice this pin is blinking, this LED right here, and it's blinking at a characteristic rate. It's on for 1 second, and then it's off for 1 second. 1 second, 1 second, 1 second, second, second. Boom. So let's try this out and do something a little different. Let's set the delay to 1/3 of a second, 333 milliseconds. 333 milliseconds. And let's recompile that. And let's upload the sketch again. So we do this. And when it's complete, you'll notice this pin 13 is blinking much faster, right? It's blinking 3 times a second. 1, 2, 3, 1, 2, 3. Okay. And so this is the basic sketch. Let's return that back to 1,000 milliseconds. And then the next thing we're going to do is we're going to add the Wi-Fi call to it to get the MAC address. Now, there is a sketch for that, for printing the MAC address. But if you wanted to know how to do that, certainly, we could Google search it. So let's say Wi-Fi Nina print MAC address. So now, Wi-Fi Nina MAC address, we click on it, and lo and behold, there is the code to do it. So we need 3 things from this. We need a data structure to store the MAC address. It's going to be 6 bytes, 2 hex digits per byte, and there are 48 bits or 6 bytes in a MAC address. And so we're going to have pairs of hex digits representing each of the bytes. And so here, you notice this MAC address, we're going to print the 0th byte in hexadecimal. So it's going to be 2 hex digits, the first, the second, the third, the fourth, the fifth, etc. And so when we print out, we're going to print out the result of each one of those bytes representing the 48 bits for our MAC address. And we're going to do that 2 4-bit chunks at a time, where 2 4-bit chunks represents a byte. So that being the case, what do we need? There are a couple of things we need. We have the include of the Wi-Fi Nina library headers. So let's copy that, and let's add that to our program file, which started out as the Blink demo. And we also need a global variable for our data structure we're going to use to store the MAC address. So we say byte MAC 6, go back to the IDE, and there's our data structure. So now that we've included the library and we have the data structure, we're going to go ahead and we're going to populate it. And we're going to populate it inside the setup routine. You could do it during the loop, but the problem is doing it in the loop, it's going to do it multiple times, again and again and again and again and again. So now we're going to take our code that we got from the web, and we're going to go ahead and print. So we start out and we say Wi-Fi begin, and this Wi-Fi begin is how you start the Wi-Fi subsystem. But we also get a status from this because we need to know if the Wi-Fi system is connected, but you don't necessarily have to be connected in order to get the MAC address, because the MAC address is not based on the Wi-Fi connection, it's based on the network card. So I'm just going to copy this call to Wi-Fi MAC address, and I'm going to go ahead and include this call. That's the wrong one. Include this call in my setup routine. So I call Wi-Fi MAC address in my setup routine after setting my digital I/O line to be output. And so now I go back to my web search results and I add all these serial prints. Now, when you say serial print, it doesn't have a new line on the end, but when you say serial print line, it adds a new line. So if we put this print statement, set of print statements here, we'll see we print out MAC colon, we print out the uppermost hex digit, 2 of them, because it's a byte, and then we print colon. So we have hex digit, colon, hex digit, colon, hex digit, colon. And then we do that 6 many times. And so here, we're printing out the MAC address, and that last print is a print line because we have a new line character. So let's now take our board and we're gonna compile this. And so I've done 2 things here. I started out and I used the Blink demo. I added to the Blink demo that bootstrap of the serial monitor to get the serial runtime running. And then I Google searched the Wi-Fi Nina MAC address print example, and I just copied and pasted that. So let me go ahead and let me compile that. And before I run it, I'll direct your attention to the serial monitor. I go to the upper right-hand corner, click serial monitor, and you'll notice here, now I get this console. This console is going to show all of the text printed as a result of calling serial print. Okay, so now let me upload this sketch. We'll do the staging. And when I do the staging, upload complete, let me go to the serial monitor. It'll take a second or 2 to connect. And let me go ahead and select my port. Let's see. Wi-Fi, nope, another port. Wi-Fi revision 2. Bluetooth incoming, that's not correct. Show all ports. No, let's do this. Serial monitor. Let me exit this and let me restart my IDE so that I make sure that it locates the board. And I don't want this one. Let me do that one. Did I just lose my sketch? Yeah, I just lost my sketch. Oh no. Oh. Let's go to examples, basics, link. I think I might have this. Yeah, so let's do this. So let me save as, and let's call it my Blink and Mac. Okay, so let's just go through that again. We have our Uno here. Okay, so now let me go back to my web search example. Don't want that connect attempt. I'm going to say serial dot begin. 9600 baud, while serial, well, not serial, empty statement, compile that, make sure I save it, compile that, upload the sketch, links, okay. So now we go back to our web search results. We include the Wi-Fi NINA library definitions. We number sign include. Let's see, we have the data structure we need. We have our print statement or MAC address. We compile that. We upload the sketch. Run our serial monitor. Let's restart. Click our restart button. Select our board. There's our MAC address. Let's unplug this and let's plug it back in again. Serial monitor. And there's my MAC address. Tell you what, let's do this. Because I want to run it multiple times, let's do a serial print line before we print out the MAC address, right? So serial print line. That'll just give it a new line character. And then let's just be, maybe we should be a little fancy, huh? Let's say this is my MAC address. Okay, so let's see, we compile that and serial print line. So we save and we compile. And then after we save and compile, we upload. And now go to serial monitor. This is my MAC address, and that's my MAC address. And so here we have the Blink demo running. And we have the output, which is our MAC address. And so you might want to put a few print lines before it and a few print lines or 1 or 2 after it, so that if you run it multiple times, you won't get this garbage output. Now you notice if I push the reset button, that triggers a power cycle. It runs setup once again. Reset button again. You'll notice prints again. So this is a walkthrough of our task sheet, and it's really important to use Google and search, to take your time, and to make sure that you follow the steps. And it's going to be really important to verify what your operating system platform assigns as a port number for your board. That's part of the protocol, because without knowing that, you won't know where to associate your board, because the IDE won't know where to send the bytecode for staging. And so there's a drop-down list, you can see here, that drop-down list will be an enumeration of all your ports. Now, on Windows, it might be COM1, COM2, COM3. On Linux, it would be a device file. On Mac OS, since it's Unix, BSD Unix underneath the covers, it will also be a device file. And so it's really important that you select the proper port for talking to the board from your IDE, but make sure you follow the instructions, the steps. Locate the IDE, install the 2.0 release candidate, the latest one, navigate through the menu choices, familiarize yourself with the menu choices before you go further. Go through the IDE preferences, set verbose output for the compile and upload. Choose your working directory because that's where all of your code is going to go, and make sure you verify that your board is accessible, what port is being used to represent your board. Install the board manager. That's really important. Without the board manager, your IDE installation won't be able to talk to the board. Locate and download the Wi-Fi NINA library. Don't go through the menus. Download the library from the Arduino website, and then go into your IDE, sketch, include library, add zip library. Do nothing else but add the zip library, not other methods. And then once you've done that, try the Blink demo from the example, and then augment it to add the Wi-Fi NINA library. How do you do the Wi-Fi NINA library stuff? Okay, you go and you do a Google search, which is all that I did. So you say, okay, Wi-Fi NINA print MAC address. Search that, first search result. There is your answer. You include Wi-Fi NINA. You could also include the SPI if you want to. Then you just call Wi-Fi MAC address, but we want to make sure that your serial port has been initialized. And that's precisely everything that you need to do. So don't get frustrated, tinker with it, have fun with it, but make sure you follow the instructions. We started out with the Blink demo, we saved it as a different name, and then we looked up the Wi-Fi NINA library, added some serial.prints and print lines, and there we have our answer. Please let me know what is your MAC address, because that's going to be needed to attach your Arduinos to the network at Clark. Okay, so with that, I'll end here, stop the recording, and I'll see you next time.